This is a presentation Wyken Seagrave gave to the Derby Scientific Club on the 10th of February, 2009, with the title History of the Universe, Fact or Fiction.
About an hour.
Must finish by 3, please.
Down. Oh, right, 2. An hour and 5 minutes. I'm going to speak for about half an hour on the history of the universe. Just a quick zip through. And then the second half, I'm going to talk about how we tell that story as a work of fiction. So, this is me. I work for a group called the British Science Association. It was called the British Association for the Advancement of Science until they changed their name last month. There's a long story to that. We promote science and engineering and do all sorts of stuff, including National Science and Engineering Week in March. I'm the East Midlands Regional Officer. So, history of the universe can be told, we more or less know most of the history of the universe. There are some uncertainties, like we don't know how it started, we don't know why the Big Bang happened, we don't know how life began, we don't understand how human consciousness works, and we don't really understand how the galaxies formed. I mean, there are a number of uncertainties, but we've got the general picture, and I'm going to tell you the general picture today of where we've come from. And I think there are a number of benefits to doing that. First of all, it forms a natural sequence, and everybody loves a good story. It can be related to everyday life. But, I mean, the real benefits aren't on that slide. I think the real benefit is that if we don't understand where we've come from, then we've just plopped down here like children. You know, and the result of that, I don't know how many people are religious here, but the result of that originally was that people invented stories about gods, and all sorts of different stories were invented about how we came here, because people have a need to know where they've come from, I think. And if we don't know where we've come from, then, as I say, we're a bit like lost children. If we do understand where we've come from, then we can see trends and patterns in the past which can help us to predict the future. And that's one of the important things that we get out of the story. There's a number of benefits. There are a number of problems involved with telling the story. One is that there's quite a lot of information. You have to cover most of the branches of science, but you don't need them in great detail. So there's a little bit of information overload, and what I would like to see would be to have science courses at schools structured around this so that we cover the complete range of science, because telling the story, you see everything. You see everything that there is, because the history of the universe encompasses everything. I can't think of any branch of science that doesn't fit in there somewhere. And so I would love to see science taught in this way. Another problem is that, you know, how do you relate to it? And one of the things that you need to do is to think about, how do I relate to the other living things? How do I relate to the Earth? How do I relate to the universe? But those are questions that people ask themselves anyway. And I think that by talking about this subject, you can get those relationships. Okay, let's do a quick zip through the story then. One of the things that you need to understand in order or to try and grasp is the quantity of a billion. If you have a cube, a metre cube, you'd have 1,000 millimetres along the side. There'd be 1,000 millimetres that way, so the top would be 1,000,000 square millimetres, and there'd be 1,000 downwards, and so there'd be 1,000,000,000 cubic millimetres. So that, you know, the average table here has got 1,000,000,000 cubic millimetres, and the number billion is key in the story. It comes up over and over and over again, and so it's nice to get a grasp of a billion. There are six or seven, maybe 7 billion people in the world today. There are about 100 billion stars in the galaxy. There are 100 billion galaxies in the universe. The Earth is about 13 billion years old. And so the word billion crops up over and over again. Scientists don't call it billion, they use the word giga. It's the same thing. So a gigabyte, if you've got a hard disk drive which is I just bought a 500 gigabyte hard disk drive for 50 quid. That's got 500,000 million bytes on it. And in fact, there's another number coming in now because of computer storage. 1,000 gigabytes is a terabyte. Anyway, so that's one number that you need to know. The scale across the bottom is supposed to show billion years. So that silly man, that would represent 8 giga years. 8 billion years ago, which scientists would call 8GYA, which stands for giga years ago. So if you looked in a geology book, you'd see GYA. So basically, I'm using the scale across the bottom to try and indicate where we are. We think the universe was created about 13 to 14 billion years ago. And we're obviously here now, at 0. So that's going backwards. So time just wait. And some dates are very uncertain, so I put a question mark on them. So that's the time scale. Right, so the creation of the universe was about 14 billion years ago. Started, we think, with a large explosion. In fact, it started, we think, with a small explosion, which then, through a mysterious process called inflation, produced a big explosion. So the Big Bang was actually the second phase. There was an earlier phase where a small amount of energy or negative energy or something like that was released, and then because of this inflationary process, the universe went through what we normally call the Big Bang. And out of the Big Bang we got particles, and there's a lot could be said about that, because according to theory there should be an equal amount of matter and antimatter in the universe. And one of the mysteries, where did the antimatter go? Won't worry about that at the moment. Out from those particles, once the universe expanded, it cooled, because the same amount of energy was spread out in a thinner space. It cooled down, and the particles began to stick together. And then we could talk about why do particles stick together, and that introduces the forces, the nuclear forces and the electrical forces that hold things together. From our point of view, the important thing is that we got atoms out of this. So atoms are particles that are stuck together. And here's one of my images of an atom. And we got the two smallest kinds of atoms, hydrogen and helium. We then go forward about 3 or 4 billion years. Maybe a quarter of the history of the universe is slipped through, about which we know not a lot. With the more powerful telescopes, we're learning more and more about what happened in those early days, and we can see some of the very early galaxies, but we're not really sure how galaxies formed. It's one of the unknown parts of the story, and there are various different theories about it. This is a picture of the current galaxies. There are about 100 billion galaxies in the universe. We live in one of them. And each of those galaxies has got about 100 billion stars. And then we could talk about different types of galaxies. And as you can see, they're not smoothly spread out. They're clumped or clustered together. And in fact, the universe has got a structure a bit like foam. If you imagine a dish or a bowl or sink full of suds. The film of the suds represents the galaxies. They're on walls and layers, but most of the universe is the empty space between them. So they're sort of empty bubbles with the galaxies on the walls. And there is another mystery, of course. There's the missing energy that we can't see, missing matter, so-called dark matter and dark energy, and all that can be talked about at this stage, but we ain't got the time today, so we're going to move on. At some point, the galaxy we live in, which we call the Milky Way Galaxy, was formed. It's a pretty typical, ordinary galaxy. As far as we know, there's nothing special about it to distinguish it from the 100,000 million other galaxies in the universe. That thought alone to me is a complete mind-boggling idea that we live near one star, the Sun, which is one of 100,000 million stars, which is in a galaxy which is one of a... I mean, these numbers just bring our problems. I mean, okay, yes, you go home and you've still got the problem of what to cook for tea, and you don't live with these issues all the time. But I think that if everybody sees this kind of scale at least once in their lives, then it affects us in some way. It puts us into some sort of proportion. And it might be frightening or it might be exhilarating, but it's part of being a human being. It's part of our culture. I think that we should understand this. Quick story about how stars grow. So most of their time is spent in the main sequence. The Sun is at that point in its life now. It's been there for about 4,500 million years. In other words, 4.5 of these billion years. And it's got about another 4 to go. The Sun's in the middle of its life. When it ends its life, like all stars, it will become a red giant, and this represents the Earth here. So the Earth will be burnt up in another 4,000 million years. The Sun won't actually probably end as a supernova because it's not big enough, but many stars do. And in the early universe, about 8,000 million years ago, these supernovae were very important because they are the powerhouses where new atoms, bigger atoms, are made. And if the universe only consisted of the hydrogen and helium that we've seen so far, it would be very boring. The fact that it's interesting is because we've got new atoms produced here. And in fact, we get new atoms produced all the way along. Inside the Sun, we're getting some smaller atoms produced. And inside red giants, we're getting more atoms. And supernovae are producing even more atoms. But the important thing about supernovae is that as well as producing more atoms, they release the atoms. So stars are the factories where bigger atoms are cooked. In fact, that's what gives the stars their energy source by fusion. Stars are nuclear fusion reactors. So when people are afraid of nuclear power, we live by nuclear power. It's out there. Okay, it's a long way away, so maybe it's fairly safe. But anyway, it's fundamental to how we live. Stars are the fusion reactors, but then the supernovae scatter them out as dust. And if they didn't, then we would never be here, because we are made, most of the atoms that we're made of, apart from the hydrogen, were made inside earlier stars during the main sequence. Some of them were made during these later phases, but most of them were made. So we are stardust. We are the product of stars. We're made of basically 4 different kinds of atom: hydrogen, oxygen, nitrogen, and carbon. If you understand the personalities of those 4 atoms, and they're quite distinct. Hydrogen's I think of it as an atom with 1 arm. It's got a valency of 1. Oxygen's got a valency of 2. It's got 2 arms, and it can form bonds with 2 other atoms. Nitrogen's got 3 arms, and carbon's got 4. If you understand those 4 atoms, you understand most of chemistry, most of organic chemistry. So anyway, that's all about stars. Lots of good stuff to be explained in there.
That was part 1 of a presentation Wyken Seagrave gave to the Derby Scientific Club on the 10th of February, 2009, with the title History of the Universe, Fact or Fiction. For more information on this topic, visit www.historyoftheuniverse.com. In the second part of the presentation, Wyken will follow the story of the evolution of life on Earth. In the third part, he explains how he tells this story as a work of fiction. For all 3 parts, visit www.timecrystal.co.uk.